All right, so problem 25. A 1960 census result indicated that the age at which American men were first married had a mean of 23.3 years. It is likely suspected that young people today are waiting longer to get married. Want to find out if the mean age of first marriage has increased in the past 40 years. So you got to write appropriate hypothesis, test the conditions, describe the approximate sampling distribution model for the mean age in such samples, and then we got the men in our sample married at an average of 24.2 with a standard deviation of 5.3. What's the p-value? Explain what the p-value means, and then what's our conclusion. Okay? So let's go through this. So we're going to write our hypothesis. So really, I'm going to go through this. I'm going to go through phantoms, okay? So what is our parameter? Well, mu equals the mean age of men when they first marry. Okay? So what's h? Well, mu h of o is mu equals 23, and the alternative is that the mean age has increased. Okay. The assumptions and conditions, we got random. Okay. So in this case here, this was a random sample. We have independent. Okay, so that means that each man's marriage age is independent. We got 10%, so our sample size is 40. 40 is less than 10% of all men. And then we have normal. Now, what's the deal with the normal? We don't have a distribution to look at. No, but we do have a sample size. And since n equals 40, our sampling distribution is likely to be normal. So our sampling distribution, because remember, small samples, we actually need to see the sampling distribution. Once samples are 40 or more, then they tend to be normal. Is likely normal. Okay? You know, the actual distribution itself will probably be slightly skewed right, because most men tend to marry in their early to mid 20s, and then less men in their late 20s, and even less men in their early 30s, and then so, but the sampling distribution is likely to be normal. So the name of this is going to be a t-test. Test statistics. Now in this we know, what do we know here? Well, we know that x bar is 24.2. We know that s of x is going to be 5.3. Okay, that's told us in problem B. N is 40. So our degrees of freedom is 39. Okay. So now we're going to obtain P. So T is going to equal 24.2 minus 23.3 over S over the square root of N. Okay. And then we're going to go to stat test. T-test, we'll go with stats. So what's mu? Mu is 23.3. X bar is 24.2. Standard deviation is 5.3. And N is 40. And we're doing greater than, so we're going to draw. Okay? So there is our distribution. So I don't know if you can see that, but P is 0.1447 and T is 1.074. Okay, so we're going to draw that. So T equals 1.074, shade to the right. Okay, we think that mu equals 23.3. This comes out to 0.145. That's our p-value. Okay, make decision, fail to reject H sub O at the 0.05 level, and state the conclusion. Okay, there is no evidence that the mean age that men marry the first time not times, has increased. Okay. And then the last thing we basically have to do is we got to explain this p-value in context. So if the mean age is 23.3, there's a 14.5% chance, okay, of getting the mean in our sample or higher if this is true. Okay, so let me restate that. Okay, there's a 14.5% chance of getting a mean of 24.2 or higher if the mean age of which men first get married is 23.3. Okay? So that's what our p-value means in context.